Now let's speak about Newton's second law. Now Newton's second law says that the vector sum of the forces on an object is equal to mass times acceleration. And they're saying, as a little side note, acceleration is produced when a force acts on a mass. So let's see what this means mathematically. So the vector sum of forces on an object is equal to the mass of the object multiplied by acceleration. Okay, so here we can see that if we have some kind of net force, okay, so some kind of sum of forces which is not equal to zero, then over here we're going to get some kind of acceleration. Okay, because we're assuming that our mass is never zero, and also when we're dealing with relativity, then we'll be dealing with changing mass. However, here our mass is a constant. Okay, so when we have some kind of net force acting on some kind of mass, that means that in order for this equation to work out or to make any sense, that means that we're going to have some kind of value for acceleration. Now, because we're dealing with the vector sum, our force is a vector and our acceleration is a vector, that means that we can split up everything into the different components. So let's say we're working in Cartesian coordinates and we have x and y, so we can say that the sum of the forces in the x direction is equal to mass multiplied by the acceleration in the x direction, and we can say that the sum of the forces in the y direction is equal to the mass multiplied by the acceleration in the y direction. And of course, if we have a z direction, it's the exact same thing. That's the end of this lesson.